Hi everyone, welcome back to my channel. Today I'm going to show you how I built a AI-powered self-driving car simulation using Python, Kivy, and deep Q learning. The goal is to train an AI agent to navigate the track and avoid obstacles and reach the target using reinforcement learning. Kivy is used for the graphical user interface, PyTorch is used for deep learning, and NumPy is used for handling the environment data. Here we can see a car, this is a AI agent trying to learn the environment. So it is trying to learn what is track, what is a grassland, and what is a sand area, and what are the other obstacles. So using the data, the whenever the car is going on the track, it gets a higher reward, and whenever the car is moving on any obstacle, it gets a negative reward. So based on that, the AI agent learns and helps the car navigate on the track. So let me break down what are all the components that I have used in this particular project to train an AI agent. So first of all, we have a car object. So the car object, as you can see, consists of a car and it has got a three sensors. So one to identify the right obstacle, the other one the front obstacle, and the other one is used to identify the left obstacle. Uh, the, um, we use this Kivy class object. In the Kiwi class object, we define the car object. So basically, we define the car UI, size, the origin, and other the sensor placement and other things. And the main thing is like we have the environment. The environment is nothing but the city map, which defines the grassland, the obstacles, and the track. And we create a mask out of this particular environment to teach the car which is a track and which is a non-track area. So you see wherever there is a track, we have marked it with the black color, and wherever there is a non-track area, we have left it in a white color that indicates the sand or the other obstacles. So whenever the car is navigating on the black color, it gets the higher reward, and whenever it moves out of the black color, it gets the negative reward. So this is the environment which is going to teach our AI agent. And now comes the brain of our network. So that is our a deep queue network. The deep queue network decides the best action that the car needs to take based on the sensor input. So the sensor is basically going to tell whether it is on the track or it is on the sand area or any other obstacles. Based on that information, we pass it to our neural network. So our neural network is going to take the sensor input and it is going to output the actions. So we have a replay memory. So the replay memory is a very important memory area which is going to store the past experience of the car. So based on what state, what action the car has taken and what is the reward it has got. So that history is going to be maintained in this particular memory. And during the training or during the learning of the network, this information is going to pass on to the network and then it is going to take action on the previous experiences. The loss is going to get computed based on the previous experience and it is going to be back propagated and the network is going to learn based on it. So here the loss function we are having is a L1 smooth L1 loss. So we are going to calculate the the best possible outcome based on the softmax value. So it is going to output the left probability, the left turn probability, right turn probability, and the front probability. So whichever is having the highest is going to be taken as the best action, and then we are going to compare it with the previous experience that was learned in our the replay memory, and the loss is going to be back propagated. So this is how the network is going to learn based on the action that is going to take, and the rewards are going to be assigned. So now we have something called as a map class. The map class is what going to initialize the environment and position the car, and it is going to move the car based on the neural network's action output. Also, it is going to assign the reward whenever the car is present on the sand, it is going to assign with the negative reward, and whenever the car is going to be on the track, it is going to assign a higher reward. So this is how the the agent is training the car, and we can see the car is like exploring the environment, and it is going to learn which is track and which is the non-track area. So you see right now it is like going on the grassland, and as soon as it finds a road, I mean it finds a track, the speed of the car is going to increase. This way, the car identifies to learn the track and the non-track area, and it is like yeah, whenever the network converges, it'll have the entire idea on like how to drive on a track and where to go and where not to go. So, what is my next plan of actions? So, my next plan of action would be to add more complex tasks and introduce more dynamic obstacles, and maybe even try a real-world application with OpenCV and a camera sensor. So that like placing the camera sensor on the toy car and help the toy car, navigate through the real-world environment. And yeah, if that is so we are able to achieve that level of training and the AI agent is able to, navigate a car autonomously, then we will have a wonderful self-driving car experience. So you can see in the image, the car has almost learned the track and it is like trying to navigate across the track. Yeah, in a few iterations, it will be completely able to learn the track and successfully it would, take several laps of that particular track. Yeah. If you found this video helpful, hit the like button and subscribe for more AI projects. Drop a comment if you have any questions or suggestions. Thank you so much.